So somebody tell me what a fossil is. What's a fossil? Chris, what's a fossil? Okay, so it's the remains of those organisms, right, that were once living. Very good. And so what kinds of things can be fossils? Give me some ideas. Do you know how old fossils usually are? At least how old, Elizabeth? My research showed me that to be considered a fossil, it had to be at least 10,000 years old. Is that right, Mr. Ogle? Okay. So about 10,000 years old. What do we call the study of fossils? Does anybody know? What's the name of this tool right here? This one? Triple beam balance. What do we find with the triple beam balance?
Mass.
The mass. Okay. So there's a plate there. And on that plate, you're going to see a team name. Okay? You're going to see your team name. And the reason that that's important, you know what I forgot is the computers. We'll get it. The reason that that team name is important is because I'm going to try to remember to call you by your name if you're the Tiger Sharks. And all the adults are going to try to do that as well. Okay? So that's your team name. And while you're waiting to be called to do something, you're going to get to do some research on your organism. Okay? And we're going to get the Chromebooks down here in a minute. I'll have Ms. McGuire bring them. All right? So there's a paper on your desk that in your time when you're waiting, you can do a little bit of research. Okay? All right. What's this called?
Beaker.
This is a beaker. I want y'all to find the mass of that beaker, and then I want you to record it on your chart. Okay? The next step says that we're going to find the mass of the beaker with a matrix. Okay? This stuff that I think kind of looks like cement is what our matrix is. Okay? And this is where we're going to make our discoveries. That sediment.
It's sediment.
It's sediment with other things.
So in Texas at one time was, I don't know if you remember when I was here, Texas at one time was underwater. Do you remember that?
Yes.
And when it was underwater, there were lots of critters that were swimming in the oceans. Like whales, sharks, yep, all these other critters. But what happened when the ocean receded, all that sediment from the ocean was left behind. And then what you're looking at today is some of that ancient sediment. Now this comes from a mine close to Dallas, Texas. And in that mine, they're digging through this stuff in search of something called aggregate. You know what aggregate is?
No.
How many rode a bus this morning? Okay. How many rode in a car this morning? What do you think the road is made of? It could be tiny little pieces of stone, right? Or if we walk on a walkway, like the concrete, that contains what's called aggregate. There's also limestone. So some of the buildings that you see out here have limestone in the buildings. So they're digging in these mines, and when they dig through the mine, they're digging through this sediment. So we went in and took some of this sediment from this ancient ocean and brought it back to you. So you're digging in that, which sort of looks like concrete, but it's ancient marine sediment that's 89 million years old.
Wow. So this is what we'll find our discoveries in, okay? So this is what you're going to do next. We're going to call you 2 groups at a time, okay? When you come up, you're going to bring your beaker, and we're going to, watch me, okay? This is important. I'm going to show you how to do this. You're going to scoop down in here, and you're going to measure out 150 milliliters. So know where that's at on your beaker before you come up here. 150 milliliters of the sediment. Okay? So, guys, 5th graders, I've already said this once today. When we look and see what we have, how do we look at this? Do we hold it up here? What do we do, Nani?
Level.
Eye level, right? And that doesn't mean holding it up. That means putting it on a table and getting down here eye level. We want to be as accurate as we can. So once you put, it's rainier today, so you may not have to do this as much. But once you think you're close, tap it on the table to make sure there's no air in it, or, make sure it's settled good. Okay? If we all got 150 milliliters, why are the masses different? What are some possible reasons that that could be different? First of all, what do we call these tools right here? These are sieves, aren't they? Are these the kind we used in the classroom? No, this is a different kind, but it's still a sieve, okay? And what do y'all notice? Is there a difference in the two?
Yes.
Lewis, what's the difference?
Well, one has tinier holes.
One has tinier holes. Why do you think one has tinier holes? Be careful,
Keep
don't
all the
spill it.
sediment in, and the other ones to get the water out and keep all the sediment in.
Okay, so you think more sediment will go through this one, the larger holes? And maybe this one will trap more sediment? You see what I'm saying? I don't know if that made any sense, but I think y'all get me. Okay, so we're going to use two different kinds of sieves for this, okay? This is where we're going to clean our matrix up and see what we can find, okay? So the larger sieve is going to go on, or the sieve with the larger holes is going to go on top, okay? Now, I'm going to ask the 5th graders to be the ones to hold the sieve because your hands are bigger and you have to keep them together, okay? So, guys, when you put your sieve down in the water, 5th graders, look, it's submerged in the water, but you can't drop it. And you don't want to go too far because this is our data, and we don't want to lose any of our data, okay? So, what you're going to do next is you're going to pour your data. 5th graders, remember, you're going to be the ones holding the sieve. They're going to help clean, but you're going to hold it. You're going to pour your data. Pour your matrix into this top sieve. Okay, now we want to get all of it out of there because it looks like there could be some good stuff in there. So how could I get the rest of that out? How? Fingers, one way. What if I put this down in the water and get a little water in the beaker? Why did I hold the beaker over the sieve?
So the sediment can get in.
Okay, I sure don't want it. I had a group yesterday that didn't do that and they lost a lot of data. Okay, so hold it over the sieve. Kind of get a little water in there maybe and slosh it around. Yeah, I might have done. Ooh, I heard something hit. But you want to get it all out of there, okay? So once you've got it all out of there, that's close enough. You're going to make sure you get it all, okay? Once you get it all out of there, now here's the part where you're going to get your hands on it, okay? We got to clean it off. So we need those, y'all make it splash a little. It's okay, okay? It's just water. We need to clean it good. And you see what's happening? What color's the water turning when I put that in there?
Mucky.
Somebody said mucky. That's a good word. Okay, kind of a brown. Now look, when I pull it back out, you see all that gray still? We want all of that off of there. So you're going to have to, kindergartners and 5th graders are going to take turns, and you want to scrub. You're going to have to rub it hard. You want to get all of that gray off of there, okay? So when you're done, it's going to be all black, okay? And at that point, we're going to come around and we're going to tell you what to do, okay? But right now, in 5th graders, when you put it in, shake it a little, let them rub. Shake it a little, let them rub, okay? Does that make sense? And then we'll come check on you.
You have little plates that you have your team name on, right?
Yeah.
So then we're going to take this top one and we're going to dump it on the plate. We're going to set it off to dry. Then you'll go back to your station with this one here and lay this on top of your second plate. And then we'll wait for further instruction, okay?
We're not out yet.
A little bit of work.
Okay, now put it on the ground and then do the next one. Now rub it around. Rub it around.